Hey guys, Alexander here, and welcome to the Probability Theory playlist. In this playlist, I will be introducing to you the crucial concepts necessary for the pursuit of your studies in probability theory and mathematical statistics. So let's start off with some of the basics first. We have to crawl before we start running, after all. So let's start with random variables. Well, what is a random variable? A random variable is a variable whose value is determined by the outcome of a random experiment. So let's say that we're flipping a coin. We've got a coin, we can either have a head or a tail. And we are counting, we let a random variable represent the outcome. So we say, let x be the outcome of this flip of a coin. And if it's a head, we say that x is equal to 1. If it's a tail, we let x be equal to 0. We code x to be equal to 0, so we have had a failure. And if it's a heads, we have a success. We want to model the outcome of the flip with heads being a success and tails being a failure. Then x is a random variable because it's modeling the outcome of the flip of a coin. And it's a variable whose value is determined by the outcome of a random experiment. That flip of the coin is randomly determined. We're not forcing it to be heads, we're not forcing it to be tails. If it's just a flip of a coin, it's randomly determined. And it's randomly determined with a probability that is not yet determined. If it's fair, then we know that that probability is going to be a half. Because if it's fair, it can either be a heads or a tail with the same probability. Or if it's a biased coin, then you will have different weightings for either the success or the failure. So there are two types of random variables that we will be discussing here. Discrete random variables, they assume countable values, for example, 0, 1, 2, 3, all the natural numbers. So a discrete random variable can only take on a countable value. It can only take any set from this natural numbers. It can go from, say, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, for example. It can't take any decimal or fractional value. It can only take the whole number values of the natural numbers. Okay? So the continuous random variables, they assume any value in one or more intervals. For example, any value from 0 to 1, excluding 0 and 1, of course, because these are open brackets. So it can be 0.1 or it can be 0.5, for example. They can take on decimal values. They can even take on 0.11111, for example. Or it can even be the interval from 0 to infinity or negative infinity to positive infinity. So continuous random variables assume any value in one or more intervals. Discrete random variables only take on countable values that are such as 0, 1, 2, 3, any subset of the natural numbers. So let's look at the probability distributions that we will be discussing in this playlist. The discrete distributions that we'll be discussing are the Bernoulli, binomial, geometric, negative binomial, and the Poisson distributions. Each of these are listed in the order in which they are discussed in the playlist. So we will first be starting off with the Bernoulli distribution, moving on to the binomial, then to the geometric, negative binomial, and the Poisson. After we've covered the discrete distributions, I'll be introducing you to the continuous distributions. In particular, the continuous uniform distribution, the exponential distribution, the gamma distribution, the normal distribution, and last but not least, the chi-square distribution. So these are all the distributions that we will be discussing and you will be exposed to in the playlist that I have created. What's the general format of the playlist? Well, the playlist starts off with the basics that you need to understand before you can tackle discrete and continuous distributions. It also includes moment generating functions. We will be discussing how we arrive at moment generating functions, what their definitions are, and some special properties that they possess. After we've done this introduction and this discussion, we will progress to cover the discrete probability distributions, the 5 that I've previously listed, and we will then move on and cover the continuous probability distributions. Each distribution is split up into 3 videos. The first one will cover the introduction to the distribution and what it is used for. The second will discuss how we derive the mean and the variance of this distribution. I will usually provide you with some tips and tricks that will make this easier for you, and I want you to be able to derive the mean and variance on your own so that you can be satisfied with knowing that those are the results because you've done it yourself. You should not just accept something that someone tells you. You should try it for yourself and see if it is indeed the case. And lastly, I will give you some tips and tricks as well as the techniques that you should employ to derive the moment generating function for all of these distributions. So good luck. I hope you'll enjoy this playlist and I hope it will be beneficial to you. Thank you very much for watching and good luck. Boer Commander out.